FCU parenthesis ClO2, 2. This is also an ionic compound. The cation is in the front. The anion is at the end. As I mentioned earlier, within a parenthesis, generally it is a polyatomic ion. If you remember the most common polyatomic ions, when you read this formula, you may immediately recognize that ClO2 minus is the anion for this compound. Next, we need to find the charge of the cation. From the periodic table, copper is a transition metal. As we have learned in class, we cannot predict the charge of the transition metal ions. Therefore, we have to use the second method to find the charge of the cation. We can assume the charge of the cation is plus X. From the chemical formula, we only have one cation. Therefore, we multiply by 1. The charge of the anion is -1. We have 2 anions in the compound. The sum is 0. We can solve this equation to find X. You can use similar methods to find answers for these problems. Can you use a similar method to find answers for these problems? I forgot to mention that when I try to find answers for these problems, I assume that the charge of element X is X. A very similar method can be used to find the answers for these problems. To find the charge of GeO4 polyatomic ion, we need the periodic table. When we look at the periodic table, we find that germanium is directly below silica. Both of them belong to the same group. Therefore, polyatomic ion of germanium should have the same charge as the polyatomic ion of silica. If you remember the charge of the polyatomic ion of silica is -4. Then you will know the charge of the polyatomic ion of germanium is also -4. When we look at problem E, we realize that the cation is made of sodium. If we look at the periodic table, we find that sodium is an alkaline metal. Therefore, the charge should be +1. Then you will wonder, what will be the charge for oxygen in this case? Let me show you the work. This is the charge of sodium ion. We have 2 sodium ions in the compound. Oxygen is X, and we have 2 oxygen ions in the compound. Actually, if you remember, O2 is a polyatomic ion, which is O2, 2-. Let's look at the last problem.